In this video, we're going to add and subtract polynomials by combining like terms. Before we get into that, we need to figure out what a polynomial is. So we're going to look at that also. And let's review as we begin combining like terms. 21y to the fifth minus 19y to the fifth. Because the variable part, y to the fifth, is the same, we can subtract 21 and 19 and get 2y to the fifth. When we're adding, combining like terms, x squared plus x, those are not like terms because x is to the first power here. That is different than x squared. It's almost like, okay, they're both x's, so they're both apples, right? But there's many different varieties of apples. You could have, these being Granny Smith apples and these being Gala apples. Together we've got a whole bunch of apples, but by type we can't combine them. So we have x squared stays the same, but I have 1x plus 5x. That's going to be 6x. Since both of these were x to the first power, we can combine those together. Being able to combine like terms is a skill that's very important in this lesson. Okay, so we need to first define some things about polynomials, what they are, get some terminology down. A polynomial is a finite sum of terms in which all variables in each term have whole number exponents. A polynomial has this general form: a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus, that could continue forever until we get a sub 2 is times x squared plus a sub 1 times x to the first plus a sub 0. What you should see is that the exponents are in descending order from n to n minus 1 to n minus 2, n minus 3, n minus 4 until we get down to 2, 1, 0. A sub I is real numbers, and and the n sub whatever is whole numbers. That's important to know. So the exponents will be whole numbers, and the coefficients to the variable term are going to be real. The product of a number and variables raised to powers is called a term. And you'll hear me use that this vocabulary throughout the lesson frequently. A term with no variables is called a constant, and that usually, if written in the standard form, it's going to be the last term usually, if there is a constant. And then the numerical factor of a term is called a coefficient. So let's see, 3x squared. The 3 is the numerical factor and would be the coefficient. A polynomial with only one term, like what I just wrote, 3x squared, is a monomial. A binomial would have two terms, so let's see, 3x squared plus 2x, that would be a binomial. And a trinomial has three terms, so 3x squared plus 2x minus 1. In this case, minus 1, that term is the constant because there is not a variable part. And terms are generally separated by a positive sign and a negative sign. So you can see very clearly there is no positive or negative sign here, so this would be a monomial. This time there is a positive, which separates two terms, making it a binomial again. Here I have a plus and a minus, separating three terms, therefore trinomial. In this first example here, I'd like to just organize by name the expressions that were given, the polynomials that are given in this box. You'll move to this box by type, where they go. So let's first look for the monomials. This would be polynomials with one term. So I'm looking for positive and negative signs separating terms. This one has 2, so it's actually a binomial, so we'll write 10q plus 4, and that one's taken care of. The next one, I see a negative 16x. There is a minus sign, which would tell us, based on what I've said earlier, that this is a binomial, trinomial, something like that. However, the minus sign is in front. It's not separating terms. It's literally just making this one term negative. So it's going to be a monomial, negative 16x. The next one, there's 2 plus signs separating 3 terms. So trinomial, c squared plus 3c plus 4. I would like you to pause the video at this point and try to group the remaining 5 problems. I will pause as well, fill it in completely, and so all of them are going to pop up here in just a second for you to see. So if you pause, try them, you'll be able to check quickly. Okay, 6 is a constant and was a monomial. 3z to the 4th minus 8, 2 terms, it's a binomial. Trinomial, m squared plus m times n plus n squared. In the none of these category, you might have had a little bit of trouble with one of them, but this one you probably got. F cubed minus f times g squared plus f plus g. There are 4 terms here. We don't have a special name for a polynomial with 4 terms, so we just call this a polynomial. But this one, 4a to the negative 2 minus 2y squared. The exponents must be positive, so this is not a polynomial, let alone a monomial, a binomial, or a trinomial. And the temptation, because it looks like there's 2 terms, was to say that this was a binomial, but because that exponent was negative, this particular expression would be none of these. In the next example, we're going to name the polynomial and list coefficients and list constants. Alright, so in example A, we have 3 terms that are separated by a negative and a positive sign. So this is a trinomial. And they want us to list the coefficients. The coefficients are 3, negative 5, and that's it. Negative 5, the sign is attached to the number. It's attached to the term. So if I was to draw a line separating the terms, this would be positive 3x squared, negative 5y, and a positive 16. Because there is no variable, there's no y or x here, 16 is the constant. In example B, we have just one term here. This is therefore a monomial. It does have a coefficient of negative 4, which is being multiplied by the a squared. And there is no constant. Well, you could say the constant is 0 because there's nothing there. And then Example C. This is a binomial because we have two terms, x and negative 10. Is there a number being multiplied by x? Is there a number in front of the x? You may look and say no, because you don't see a number, but we remember a 1 is understood to be written there. So 1 is our coefficient, and the constant here is going to be negative 10, because the negative 10 term has no variable. Another thing we need to look at is the degree of a polynomial. But first, the degree of a term is going to be the sum of all exponents with variable bases. And then the degree of the polynomial is the same as the term in the polynomial with the highest degree. So we have to find the degree of every term and then choose the highest. Variables that have exponents are the only thing that matters. So the degree of this first term is 2. The degree of the second term, 3a cubed, is 3. And the degree of negative 4a to the fourth is 4. That was the exponent. And so the degree of this trinomial is 4. That was the highest. So I wanted the name of it and the degree. The next one is also a trinomial with 3 terms. And you see no exponent, so again we understand 1. And all 3 of them have an exponent of 1. So this is going to be a degree of 1. And in the last we have a binomial. There's 2 terms. And the 13 is a constant with no variable. So its exponent is 0. There's no variable. Anything to the 0 power is 1. But the first term has 3 variables attached to it: a squared, b cubed, and c to the first. And we remember, as we were looking at the degree of a term, it's the sum of exponents on variables. So 2 plus 3 plus 1 is 6, and that will be the degree. Now there are also names for polynomials with the different degrees, and you don't need to know all of them, but I'll go over a few. If it's raised to the 4th power, we can call this a quartic. If it's raised to the 1st power, it's going to be linear. So if the degree is 1, it's linear. If the degree is 3, it's cubic. If it's 2, it would be quadratic. If it would be raised to the 5th, it's quintic. Those are just a few. Again, those are not essential to know, but nice to know, I guess. And finally, we are ready to add and subtract polynomials. So I have a few examples for you with that. We're going to use the same rules as simplifying expressions when doing that. And I have found over the years several ways to do this, but I feel like this particular that I will show you is going to be the best. I find students make the least amount of mistakes organizing this way. So we have 12y squared minus 3y minus 9. We're going to add the polynomial negative 12y squared plus 5y plus 9 to that. Since we're adding, we're just going to combine like terms, and so I'm going to stack the polynomials by like terms and take negative 12 y squared and put that in the y squared column. I'm going to take the positive 5y and put that in the linear y column. And I'm going to take the positive 9 and put that in the constant column, and now add like I would back in elementary or middle school in a vertical organizational structure. And so we go ahead and combine like terms. Negative 9 plus 9 is 0. Negative 3y plus 5y is 2y. 12y squared minus 12y squared is 0. So the final answer in this case is actually just 2y. For number 5. This time it's a subtraction question. And where many people will make mistakes is they do not distribute this negative 1 and then turn it into an addition problem. So every sign in the second polynomial is going to change and become negative 10a squared plus 5b cubed minus 6b squared. Now this is a positive over here, and we're just adding or combining like terms. So I can take the 6a squared and put that in the a squared column, and the minus b cubed and put that in the b cubed column. And there is no b squared in this first polynomial, so we are stacked by like terms, as you see here. And we can just go ahead and add them. And we will get negative 4a squared plus 4b cubed minus 6b squared as the final answer. Two final examples. This time it's written differently. Example 4 and 5, there were plus and minus signs for adding and subtracting. This time we're saying add this to that, or subtract this from that. So we have to be careful here that we put things in the right order. If we're adding, we're just combining like terms, and the order doesn't necessarily matter. I will move the smaller of the two, so in this case the binomial, and I'll leave the trinomial put. Again, trying to stack up by like terms. So do I have a b squared over here? No, but I do have a c squared, which I will put positive 10c squared in the c squared column. And positive 8 is going to go in the constant column. We are set up, ready to add, and we have 13b squared plus 22c squared minus 14 as our final answer. But when we have subtraction, and we're subtracting something from something else, this we have to pay very close attention to. We think about, like, if you were to come to the college for class, or come to high school for class, you're going from your house to the school. So if we're subtracting this one from that, this is like our house where we came from. This is the beginning. And this then is where we're going, or school, so we're going to subtract this one. So we could write it like the last example, x cubed minus x squared minus 7x cubed plus 2x squared. Remembering we now need to distribute that negative 1 to both of these terms, changing their signs. So we have x cubed minus x squared minus 7x cubed minus 2x squared. As we distribute the negative, these all change. And to combine like terms, we can stack as we've done before and have the negative 7x cubed and the positive x cubed. We'll put those in the same column. The negative x squared and the negative 2x squared are both x squared, so we'll put those in the same column. And we will combine right here like terms and have negative 3x squared and negative 6x cubed. So we've covered a lot of ground in this video, looked at some basic definitions and terminology dealing with polynomials and what they are, as well as then adding and subtracting, which is nothing more than combining like terms. But remember to be careful whenever we're subtracting. First, you need to remember to distribute a negative to the second polynomial. The second thing you have to be cautious of is a problem like number 7. Subtract something from something else. Where it's coming from is the first one, and you will distribute a negative to the second. That's very important to remember. If you remember those couple things, you will be just fine adding and subtracting polynomials.